Okay, everybody, today we're going to look at layout managers. And we got a lot of different managers that we're going to look at. So they're broken out into two sections, layout managers 1 and layout managers 2. In addition to layout managers, we've also got a lot of components that we need to look at, including the J panel, text areas, and then radio buttons and combo boxes and all kinds of things. So let's go ahead and get started in taking a look at layout managers. Layout managers automate the positioning of components within the containers. They free the programmer from the difficult task of figuring out the space needed for each component and the pixel coordinate positions for each component. The layout manager looks at the size of the container and the sizes of the container's components. It then tries to fit the components neatly into the container. If a user resizes the window, the layout manager takes that into account and adjusts the layout accordingly. If a programmer adjusts the component size, that is, by changing the label's font size or some other way, the layout manager takes that into account and adjusts the layout accordingly as well with that. Layout managers automatically manage the flow of objects on the screen. And as an aside, they are also used heavily in mobile development. So understanding it here will help you if you ever do some Android or iPhone programming. Now in Java, the 5 most common layout manager classes are flow, box, border, grid, and grid bag. And except for the box layout, all of these layout manager classes are in the Java AWT package. The box layout class is in the Java X Swing package, so make sure you import those packages as applicable for whichever layout you're going to be using. To assign a particular layout manager to a JFrame window, call the setLayout method as follows. And here, we would replace the layout manager class right here, with the name of the layout manager that we actually want to use, like flow layout, box layout, so on and so forth. And then arguments will get replaced with 0 or more arguments depending on the layout that you choose, like this, where flow layout left is a class constant that's used to adjust how the layout is implemented. If set layout is not called, then border layout manager is used by default. So let's take a look at one of the layout managers so you have a better idea on how to actually implement one. And so we're going to start with the flow layout manager. The flow layout class implements a simple one compartment layout scheme that allows multiple components to be inserted into the compartment. When a component is added to the compartment, it is placed to the right of any component that were previously added to the compartment. If there's not enough room to add a component to the right of the previously added component, then the next component is placed on the next line. That is, it flows to the next line. By default, components are placed in a flow layout container using top center alignment. There's no way to change the vertical alignment, but there is a way to change the horizontal alignment. To do so, insert one of the flow layout alignment constants, and that's either flow layout.left, flow layout.center, or flow layout.right in the flow layout constructor call. For example, here's how you would specify a left alignment. According to the Java 7 API documentation, after a program's initial display, if the program attempts to change a container's layout, that is by adding or removing components, calling set layout, or calling set size, the change may not take place immediately. So to ensure that the change takes place, you call JFrame's validate method, like this. The validate method causes the layout manager to regenerate the Windows layout. The box layout manager arranges components in either a single row or a single column. And there's no wraparound, so long components will be partially cut off. So make sure you take care to assign appropriate window dimensions to all of your components. To specify the use of a box layout manager for a container, call set layout like this. The box layout class in the Java Swing, or it's in the Java X.Swing package, unlike flow layout, border layout, grid layout, and so forth, which are in the java.awt package. So make sure you import javax.swing when using the box layout. In the upcoming demo, we'll see how this window is created by using the box layout and 5 JLabel components. Normally, the JLabel components are instantiated by passing a string to the JLabel constructor. However, the second label component was instantiated by passing an image icon to the constructor like this. In all of our prior GUI programs, we added the clause extends JFrame to the program's class heading. By extending JFrame, that means that when the class was instantiated, a GUI window was generated as well. That technique works great if you know that you want a GUI window displayed initially. But in the upcoming program we're going to demo, we want to generate the GUI window only when the driver calls the program's print poster method. To do that, we'll call the JFrame constructor within the print poster method. The print poster method relies on the following 5 instance variables, which are used to create the Windows 5 JLabel components. So let's go ahead and take a look at the program now so you can get a better idea of what's going on. We have our import statements for our javax.swing package and java.awt package. And then we have our variables that we're going to populate before we generate our GUI window. And basically we just have a bunch of getters and setters for those properties because these are private, of course, so we have our public methods. And here is where we actually create our poster. And so here you see we have our frame, and notice that we're not, in our driver, we are not extending JFrame. In our dance recital, we're not extending JFrame, right? So we have to actually create a JFrame object. Then we're also creating a label object called picture label. And so here we're just setting the dimensions and our default close behavior. And here's where we're setting our box layout. And we have to get the context for which we want to apply the box layout to. And in that case, we have to get our content pane. And then we're saying we want to set it as a y-axis, so it's going to be in a column format, right? Then we're adding a label to the frame, and we're using the performance variable that we set, and we are specifying the font size, right? Now notice here, add label is an actual private method that we're using, right, where we pass in the context that we're using, the string, the style, and the size of the font. All right, so we create a new label, we pass in the text, and then we call labels.setAlignment, right, which we are automatically centering. And then we're setting the font to, we have to create a font object, right? And here we're using an anonymous function, or excuse me, an anonymous object. We're not actually creating a named reference for this. So we're saying it's a serif font, and we're passing in the style and size that we passed in up here. And then we're adding the label to the frame. Okay, so notice frame is our actual frame. So we've added the top label to it. Then we're creating a new picture label in which we're passing in an image depending on whatever image we specify in the display poster. So we're going to set the image right here, and then we're just going to use that variable when we create our image icon object. And then we're going to pass that image icon object into the label constructor. Next, we set the alignment of the picture. We're again centering, aligning it, and then we're adding the picture to it. And then here is just 3 more additional labels that we're adding, and again we're calling this private function add label, where we're specifying the context, what we're adding it to, and then the different variables that we want to set. And then of course we can change these font sizes or do whatever we want. Alright, so that's the class. Now let's look at the driver program, which is pretty simple, right? We have a scanner object, which you're familiar with, and then we create a dance recital object, calling the default constructor, which there's nothing particularly exciting about that. And then we just ask the user for all the information that we want to do, right? So here in this case, we'll go ahead and compile it, and we'll run it. Okay, and it says name of performance. We'll just call it my performance. And image file. In this case, I'm going to use Phantom of the Opera. And this is only looking for images that are in the same directory. We don't have any extra functionality to search outside of the directory, so this is just one of the images that I have in the directory. Dance recital's date. We could put in anything here, but we'll put in 15 May 2018. Whoops. 2018. And dance recital's time. We'll say 1600. Right? And the venue, we'll say gym. Whoops. Gym. When we hit enter, you can see here that we've created our poster. Right? Now I can extend this, and so now we can actually fit the whole my performance into the poster, right? And the poster is displayed at the size of the image that it is. But you can see here how that corresponded to that, right? So we can do it again. Let's close it out and run it. And you can see here, name of performance, yours, right? Image file. In this case, I'm going to use the author's default file, what was the name of that? Dancer.jpg. All right. So we'll just call dancer.jpg. Dance recital's date. We'll say it's 15 June 18. Recital time. It's early in the morning, right? And the revenue is, it's at your house, right? And here you can see we generated the different posters. So you can see how we imported the picture into making our poster, and when we resize it, you can see it kind of automatically centers and all that happy stuff, but it's vertically aligned. You can't change that with the box layout, okay? Well, that's it for this video. So let's go ahead, and in the next video we're going to take a look at even more layouts.